Hello everyone, in today's topic we are going to discuss about limits of piecewise function and infinity. What is a piecewise function? A piecewise function is a function built from pieces of different functions over different intervals. So supposing we have this graph, it is defined by a piecewise function. F of x is equal to x squared if x is less than 2, f of x is equal to 6 if x is equal to 2, and f of x is equal to 10 minus x if x is greater than 2 but less than equal to 6. So this is an example of piecewise function. Now let us determine the limit of piecewise function. So first we have the given f of x is equal to the square root of x plus 2 if x is less than 2. F of x is equal to x squared minus 2 if x is greater than equal to 2 but less than 3. F of x is equal to 2x plus 5 if x is greater than equal to 3. So let us determine the limit of f of x as x approaches 2 from the left. So in here, take a look at 2 and then the negative or from the left. So in here, we are going to take a look at x less than. So we have x less than 2. So we have to use this function. So f of x is equal to the square root of x plus 2. And then we are going to substitute the value of your x. So x will become 2. And then we have square root of 4, and square root of 4 is equal to 2. So that is the limit of the function as x approaches 2 from the left. Now, let us have the limit of the function f of x as x approaches 2 from the right. So in here, we are going to consider your direction from the right, or if this is positive, so we are going to take a look at x greater than or x greater than equal to 2. So in here we are going to use x squared minus 2, and then we are going to substitute the value of your x. So we will be getting 2 squared minus 2, which is equal to 4 minus 2, which is equal to 2. So the limit of f of x as x approaches 2 from the right is equal to 2. And then we are going to determine the limit of f of x as x approaches 2. So in this one, we are not going to solve. Let us analyze the limit of the function f of x as x approaches 2 from the left and from the right. So since it is equal to 2 and equal to 2, they are both equal. So the limit of f of x as x approaches 2 is equal to 2. Now, using the same piecewise function, we are going to determine the limit of f of x as x approaches 3 from the left. So in here, take a look at your 3 and take a look at your negative. So from the left. So in here, we are going to take a look at x less than 3. And we are going to use this one. So substituting the value of your x, which is 3. So 3 squared minus 2, it is equal to 9 minus 2. So limit of f of x as x approaches 3 from the left is equal to 7. Now let us determine the limit of f of x as x approaches 3 from the right. So positive, your key symbol. So if it's positive, then we are going, or from the right, we are going to have this one. So x is greater than equal to 3. So we are going to use 2x plus 5. And then substituting the value of your x. So 2 times 3 plus 5, it is equal to 6 plus 5, and it is equal to 11. Then we are going to determine the limit of f of x as x approaches 3. So here we are not going to solve, but we are going to analyze the limits of each from the left and to the right, or from the right. So since we have 7 in here and 11 in here, they are not equal. So we are going to conclude that it does not exist. D and E stands for does not exist, or we use the symbol infinity for does not exist. Again, I repeat, if your limit f of x as x approaches from the left is not equal to the limit of f of x as x approaches from the right, so your answer for that specific limit is D and E, does not exist. Now let us have another piecewise function. So in here, we are going to determine the limit of f of x as x approaches 1 from the left. So take a look at 1 and from the left. So we are going to have x less than 1, and we are going to use 7x minus 5. In here, we are going to substitute the value of x. So 7 minus 5 is equal to 2. Now let us determine the limit of f of x as x approaches 1 from the right. So it is positive, or just a clue symbol. So we are going to take a look at x greater than 1, and we will be using 3x squared minus x. Then we are going to put the value of your x, which is 1. So 3 minus 1 is 2. And then we are going to determine the limit f of x as x approaches 1. So since they are the same, or they are equal, we are going to conclude that limit f of x as x approaches 1 is equal to 2. Now, using the same piecewise function, we are going to determine the limit of f of x as x approaches 3 from the left. So take a look at the value of your x. It should be 3, and it should be less than. So we have x is less than equal to 3. So we will be using 3x squared minus x. And we are going to substitute the value of your x. So we will be getting 3 times 3 squared minus 1. And it is equal to 26, because 3 squared is equal to 9 times 3 is 27. So 27 minus 1 is 26. Now let us determine the limit of f of x as x approaches 3 from the right. So in here, if it is plus or positive, we are going to have x is greater than 3. Then we are going to use x to the third plus 4. So in here, we are going to substitute the value of your x, which is 3. So 3 to the third is 27 minus 1 is equal to 26. Since they are both equal, so limit of f of x as x approaches 3 is equal to 26. Because they are equal, limit f of x as x approaches 3 from the left and from the right are equal. So limit f of x as x approaches 3 is equal to 26. If they are not equal, then you write D and E, okay? Okay, now let us move on to the next. Now let us have the rules for limits of sequences. So the first one, limit of k as x approaches infinity is equal to k. So k is constant. And then if we have limit of 1 over n raised to p as n approaches infinity is equal to 0. So take note that p is a positive constant. And then third is limit 1 over b raised to n where n approaches infinity is equal to 0. So take note b is a constant greater than 1. And then for the fourth one, we have limit a sub n plus b sub n as n approaches infinity is equal to the sum of the limit of a sub n as n approaches infinity as well as limit of b sub n as n approaches infinity. Now let us have this fifth and the sixth rule. So the fifth rule states that limit of a sub n, b sub n, as n approaches infinity is equal to the product of the limit of a sub n as n approaches infinity and limit of b sub n as n approaches infinity. And for the last one, we have the limit a sub n over b sub n as n approaches infinity is equal to the quotient of limit of a sub n as n approaches infinity and limit b sub n as n approaches infinity. So let us have an example. So if we have the limit x to the third plus 1 over 3x to the third minus 4x plus 5 as x approaches infinity, in here we are not going to use the long method anymore, but we are going to use the leading terms rule. So in doing this, just concentrate on the leading terms with the highest exponent or power. So we have the limit of x to the third over 3x to the third because they are the leading terms of each of the rational expressions in the numerator as well as in the denominator. So first we are going to simplify. So let us cancel x to the third and x to the third. So what's left is 1/3. So we have the limit of 1/3 as x approaches infinity, and we all know that the limit of a constant is equal to that constant. So the answer is 1/3. Now let us have another example. Limit of x squared plus 1 over 3x to the third minus 4x plus 5 as x approaches infinity. So in here we are going to use again the leading terms rule, and it will become limit x squared over 3x to the third as x approaches infinity. In here we are going to simplify it. It will become limit of 1 over 3 times 1 over x as x approaches infinity. So using the rule in limits of sequences, we have limit of 1/3 as x approaches infinity times limit of 1 over x as x approaches infinity. We all know that the limit of a constant is equal to the constant, and limit of 1 over x as x approaches infinity is equal to 0. So 1/3 times 0 is equal to 0. Now let us have another one. So limit of 1 plus x squared over 1 plus x as x approaches infinity. So in here, using the leading terms rule, we have limit of x squared over x as x approaches infinity. In here, we are going to use the quotient rule. So we have limit of x to the second minus 1 as x approaches infinity. So in here, we have limit of x as x approaches infinity. And we all know that it is equal to infinity. That limit f of x as x approaches infinity is equal to infinity, or it does not exist. Now let us have a short quiz. Find the limit if it exists. So limit of 1 over square root of x minus 1 as x approaches infinity in 5 seconds. That's right, it is equal to 0. Find the limit if it exists. Limit of 15 minus 16x to the negative 3 as x approaches infinity in 5 seconds. That's right, the answer is 15. Now exercise time. Do worksheet number 7 in the Google Classroom. Please type your name, student number, and class before you answer. That's it for now. Thank you for watching. Please subscribe to my channel and see you again next time. Bye!